Today, we are going to try to access the Templar's secret by going on a hunt for a type of star from which it is impossible to return. And the problem when embarking on such an adventure is that the black holes we manage to find often have entrance doors that are very difficult to pass through. This one is busy eating a star, that one is too dangerous, too hot, impracticable, risky, hazardous. Yes, that's it, that one will do with its 10 solar masses. It is currently inactive and swallows nothing except sometimes the light that, passing too close, ends up falling into it. Astrophysicists have had fun calculating what would happen when approaching a black hole of this type, and their conclusion is unequivocal. That's why we'll stop there, just over 217 miles from the center. And to understand why going further would end up being more dead than alive, we are going to illustrate it by sending zombies there. To understand what just happened and familiarize ourselves with what could potentially kill us, let's send a zombie again, but this time let's study the scene in slow motion. Schematically, a black hole includes a central point called singularity, where all its mass is concentrated, and an immaterial boundary, a kind of surface of no return between recoverable and irrecoverable, which visually corresponds to the diameter of the disk at the boundary between light and total darkness, and which is called the event horizon. But this boundary does not necessarily correspond to the demarcation between the dead and the living. For a black hole of this mass, it's a few 300 kilometers before the event horizon where, to put it politely, the trouble begins. In this area, our zombie is subjected to the intense gravitational field, which manifests itself in the form of powerful tidal effects, stretching its physical integrity. As the phenomenon intensifies, the situation becomes very tense. In other words, it's screwed. The head accelerates faster than the feet and in insane proportions, with the unfortunate consequence of a phenomenon of spaghettification, also poetically called the noodle effect. In reality here, the fact that this black hole is relatively small is in itself a big problem. Because, as the acceleration experienced by anybody that passes through, there is inversely proportional to the cube of the distance, then the zombies take several million times. The Earth's gravity per meter in this region, each centimeter can account for tens of thousands of jets. Even arriving well-oriented, you would see your nose accelerate faster than your ears. And while the black hole wrings their neck, the remains, accelerated to speeds close to light, plunge towards the center. Let's do the same with an idea. These stars are not cosmic vacuum cleaners. The gravitational attraction they exert is identical to, for example, a star of the same mass, and therefore represents no danger if you keep a good distance like us. To hope to get closer to a black hole without losing physical integrity, we will need to find one like this, inactive and especially supermassive. Though weighing 1 million solar masses, its diameter is merely triple our sun's size. And at the distance we are, which is on the order of Pluto to the Sun, it still seems very small to us. Let's start our dive now. One might think that you don't need to be a genius to conclude that if a black hole can bend light rays, it will likely treat those who try to enter the same way, but that's not always true. And to prove it and fully enjoy the show, let's leave the ship without a suit. Because, what's the point? It's a simulation. As we get closer, chromatic aberrations appear on the edges of the disk. The light, strongly deviated by the curvature of space near the horizon, produces gravitational mirages there. The image of the starry vault, located exactly behind the black star, encircles it with an Einstein ring that shows what is on the opposite side. The black hole bends light rays, with almost none obscured. Suddenly, we begin to drift slightly. We have now entered a region called the Ergosphere. The self-rotating celestial body is a Kerr black hole, the only types of black holes that we expect to find in the universe, which drag the geometry of space-time like a whirlpool and us with it. This kinetic movement was communicated to it by everything that fell into it, stars or living dead. The absence of colors fills more and more space, and as we approach the horizon, reality begins to surpass fiction. Soon, half the sky will be in total darkness, and the other half will contain the entire firmament, as if compacted. This strange line of division is what we call the photon sphere. Here, gravity is so strong that light can perform closed orbits. The photons spin around in it. Which means that, there, it is theoretically possible to look at the back of one's own skull, because the image that leaves it could well end up, after making a complete tour of the black hole, coming back to your eyes. We are about to enter a region where the distortion of time due to the powerful gravitational field will begin to be felt. To understand the situation, we must compare different perspectives. Between us, about to pass, the horizon is an observer kept at a safe distance. From its perspective, our movements slow down, gradually transforming us into sedated sloths. Visually, we start to slow down considerably, and our time does the same as we approach the horizon. But from our point of view, time continues to flow normally, while the outside observer seems to be frantically active, as if their own time was flowing faster than ours. As we approach the horizon, the phenomenon intensifies and the observer's acceleration increases. Days of his life are now passing before our eyes. From his perspective, time continues to flow normally for him. And before we cross the horizon, he sees our image, almost frozen, slowly fading as the light rays leaving us lose energy. If he could observe us in all wavelengths, he would see our image, after leaving the visible range, losing intensity in the infrared, then in the radio wave range, before completely disappearing from his point of view. Because from another, during the last moment that we live in this universe, something crazy happens, nothing happens. But let's go back a bit and abstract from the observer to focus on the sky when we were still at the photon sphere. As the darkness progresses, the light that accompanies us in our fall gains in energy, and gradually the color of the stars shifts towards blue. Above us, the entire celestial vault is now compressed into a window that is getting smaller and smaller, in which the images become distorted and unrecognizable. The space occupied by the sky is reduced, and all that remains of the outside universe is concentrated in this small porthole that will keep shrinking, even though it still contains the entirety of the sky until it finally closes, plunging us into absolute darkness. We have just crossed, without realizing it, the event horizon, the only border of the universe that only issues visas in one direction. The virtual line from which nothing, not even light, can escape from this star, which itself definitely steps out of the ordinary. We are the first humans to enter a black hole, an exotic place that general relativity and quantum physics struggle to describe. We can only share this unsettling experience with those who, like us, have gone beyond the horizon. Everything that happens now will forever remain between us. And before we definitively leave this world where we may no longer really be, let's assume that we are still alive. Because crossing the horizon of a supermassive black hole does not imply dying. Because the acceleration that inevitably draws us towards the singularity is still for the moment negligible, and it will remain so for a very long time. For a black hole of 1 million solar masses like this one, the region where the tidal effects spaghettify is still very far away. You can make a sandwich or pull out a good book, because endowed with almost zero speed. When we've crossed the horizon, we still have a good 10 years of travel left before we end up in mush. And if we had chosen an even more massive black hole, maybe we could have, with enough to live normally there before dying of old age. Because for a black hole of 1 billion solar masses, it takes several thousand years before feeling the tidal effects. The millions of pieces continuing the adventure will throw themselves into a singularity, a rupture in the space-time continuum. As for what awaits your spaghetti once this point is crossed, perhaps it is the grand finale or the beginning of a new adventure that perhaps holds the secrets of the Templar. A passage to another universe via what is called a wormhole, a hypothetical physical object often found in the imagination of humans, but for now, never in nature. And if ever your spaghetti goes through moments of loneliness, tell them that there might be a light at the end of the tunnel. Because a hypothetical wormhole could well lead to a white hole, a kind of exit door that could lead to another universe. Thank you for traveling with us. We hope to never see you again on our lines.